Hello, and welcome to 5-Minute Math. Today we are looking at the fourth grade concept of adding and subtracting fractions. This is standard 4.3e in the great state of Texas, and we are using item number 27 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got a shaded model here, and it looks like it's some type of pattern. It's just not all the shaded parts are not connected, so we're gonna have to count those up. But the shaded model represents the fraction of classrooms that are used by teachers, and we need to find an expression here. You notice all of our expressions down here are addition expressions that can be used to find the fraction of the classrooms used by teachers. So really, we're just trying to figure out what does this model actually show. Well, let's see. What do we have here? We've got 1, 2, 3, 4, 5. Okay, so wanting to see how many total squares we have. 1, 2, 3, 4, 5, 6. All right, so we've got a 6 by 5. Okay, so we could say this is out of 30. And if we wanted to, we might be able to simplify or reduce, but we might just be able to keep it at 30. Now, let's see. How many total shaded squares do we have out of 30? It looks like it's going to be maybe half, a bit more than half. We'll see. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so we've got 16 out of 30. This is the fraction used by teachers. If we wanted to, we could simplify that, but I'm not sure that's exactly what we need to do here. But we could go ahead and do that if we wanted to, right? If we wanted to show it in simplest form, we could say, well, you can create an equivalent fraction by dividing numerator and denominator by 2. That's going to be 8/15ths. But that doesn't really help us because take a look at our answers here. We don't have anything in 15ths, and honestly, uh, B, C, and D all are in 30ths. So I think we're going to stick with this 30ths right here. Now, let's see if we can interpret what this means here. And so if we take a look at A, right, we've got 5, 6, and 5. And if you add that, you are going to get 16. But you don't, this doesn't work right here. 5/4, you can't add just like this. You have to have the same denominator. And honestly, if you look at 5/5, that's one whole. If you look at 5/5, that's one whole. If you look at 6/4, that's greater than one whole. That's like 1 2/4, that's 1.5. So if you add up one whole, 1.5, and 1, you're going to get 3.5. No, this is not even a full 30 squares shaded in, so that's not going to work. So we're looking at different ways that we can make this 16/30ths, right? And so the rest of these, we can just go ahead and just add, because when we add fractions, we have to have the same denominator, and the denominator is simply our unit. So once we have the same denominator, we keep that denominator. We then only add our numerator. So A, we were able to eliminate because it just doesn't make sense. But let's just go ahead and get our totals here. We've got 7 plus 7, 14. Close. Now look what they probably did on that 7 and 7. They did 1, 2, 3, 4, 5, 6, 7. They kind of did the white part here, and then 1, 2, 3, 4, 5, 6, 7. They did the white part here. So they did the not shaded, is what they did. Okay, we've got 5 and 6 and 5, and that is going to be 16. So yes. And then 16 and 14, that's the shaded and the unshaded to make the whole 30/30s. It doesn't work. So really, this is what they did. They just took each of these chunks. This is 5/30ths. This is 6/30ths. This is 5/30ths. They added them separately. And there you go. You have your answer, C, 5/30ths plus 6/30ths plus 5/30ths. That equals your 16/30ths.